Good morning everyone. Today's class we are going to discuss about the storage area and network. RAID levels. Application performance and data availability requirements and cost determining the RAID level selection. The RAID levels are defined on the basis of stripping, mirroring and parity techniques. Table 3.1 shown that commonly used RAID levels are RAID 0 strip set with a no fault tolerance. RAID 1 disk mirroring. Nested combination of RAID levels, example RAID 1 and RAID 0. RAID 3 strip set with a parallel access and dedicated parity disk. RAID 4 strip set with the dependent disk access and dedicated parity disk. Disk 5 strip set with the independent disk access and distributed parity. RAID 6 strip set with the independent disk access and dual distributed parity. RAID 0. RAID 0 configuration uses the data stripping techniques, where the data is stripped across all the disks within a RAID set. Therefore, it utilizes the full storage capacity of an RAID set. Shown RAID 0 is an array in which data is stripped across 5 disks. This is shown here, data from host, EDCBA, that is RAID controller. This is the disk where the data is going to store. When the number of drives in the RAID set increases, performance improves because more data can be read or write. RAID 0 is a good option for the application need high I/O throughput. However, if there is application required high availability during the drive failure, RAID 0 does not provide data protection and availability. RAID 1. RAID 1 is based on the mirroring technique. In this RAID configuration, data is mirrored to provide fault tolerance. A RAID 1 is set consisting of two disk drives, and every write the return to both disks, the mirroring is transparent to the host. During this failure is the impact on the data recovery in RAID 1 the least among all RAIDs implementation. This is because the RAID control uses the mirror device for the data recovery. RAID 1 is suitable for applications that required high availability and cost in no constraint. Is what data is from the user and RAID controller. Here we are going to store this data in mirror set, and the same data is stored in on a sheet. Nested RAID. Nested RAID, most data centers require data redundancy and performance from the RAID array. RAID 1 and RAID 1 plus 0 and RAID 0 plus 1 combine the performance benefit of RAID 0 with the redundancy benefit of RAID 1. They use stripping and mirroring techniques and combine their benefits. These types of RAID requires an even number of disks. The number in begins 4. This is a pictorial representation for 1 plus 0 is equal to 0 plus 1. RAID 1.0 is also known as RAID 10 or RAID 1 by 0. Similarly, RAID 0 plus 1 is also known as the RAID 0 1 or RAID 0 by 1. RAID 1 plus 0 performs all well for the workload with a small, random, quite intensive I/O. Some applications that benefits from the RAID 1.0 include the following: high transaction rate online transaction processing, large messaging installation, data application with write intensive random access workloads. RAID 1 plus 0 is also called as strip mirror. The basic elements of RAID 1.0 is mirror paired, which means that data is first mirrored and both the copies and data are stripped across the multiple disk drive pairs in RAID set. To understand the working of RAID 1.0, 1 plus 0, consider an example of an 6 disk forming of RAID 1 plus 0. RAID 1 is the first and then the RAID 0 is set. Their disks are paired into 3 set of 2 disks, where each set has a RAID 1 set mirrored paired of this data is then stripped across all the 3 mirror set to form RAID 0. Following are the steps performed by RAID 1 plus 0 drives 1 plus 2, RAID 1 message mirror A, that drives 3 plus 4, that's B, that's drive 5 plus 6 is C. For the following same way, this is RAID 0 plus 1, this is they are going to step performed by the RAID 0 plus 1 is drive 1 plus 2 plus 3 is RAID 0, that is strip set A, that's RAID drives 4 plus 5 plus 6, RAID 0 strip set to B here. This causes increase in unnecessary I/O load on the surviving disk and makes the RAID set more vulnerable to the disk second disk failure. RAID 3 strips data for performance and uses priority for fault tolerance. Priority information is stored on the dedicated drive so that the data can be reconstructed if the drive fails in RAID set. For example, in a set of 5 disks, 4 are used for the data and 1 for the priority. Therefore, the total disk space required is 1.25 times the size of the data disk. The RAID 3 always reads and writes complete strips of data across all the disks because the drives operated in parallel. There are no particular partial writes that updates one out of many strips in strips. Figure 3.8 illustrates the RAID 3 implementation. RAID 3 provides a good performance in application that involves large sequential data access such data backup and video streaming. This is what the RAID 3 digital representation data from the host and is stored in the data disk and priority disk is generated. Similar to RAID 3 and RAID 4 strips data for the high performance and uses priority for the improved fault tolerance. So data is strips across all the disks except the priority disk in RAID. Priority information is stored as a dedicated disk so that the data can be rebuilt if the drive fails. Unlike the RAID 3 data disk is RAID 4 can be accessed independently so that the specific data elements can be read or write on a single disk without reading or writing on entire strips. RAID 4 provides good read throughput and regional without throughput. RAID 5 is a versatile RAID implementation. It is similar to RAID 4 because it is used stripping the drives are also independent accessible if the difference between the RAID 4 and RAID 5 is a parity location. In the RAID 4, parity is returned to a dedicated drives, getting a write bottleneck for the parity disk. In the RAID 5 parity distribution across all the disks to overcomes the write bottleneck of the dedicated parity disk. Listed the RAID 5 implementation. RAID 5 is good for random read intensive I/O application and preferred for managing data mining, medium performance media serving and null database management system, that is RDBMS implementation, in which data administration DBS optimize data access. This is about RAID 5 here. Your data is stored with the priorities. Thank you.